All right, video 5. Here we get into transmutation notation. Little bit of math, but same properties as before when we talk about reactants and products. The mass on the reactant side has to equal the mass on the product side. The number of protons on the reactant side have to equal the number of protons on the product side. Reactant side, product side, reactant side, product side. Okay, so here are our learning targets. We're going to get into some notation, and then we're going to get into half-lives. Yeah, half-life. So here we go. Total mass charge of protons of the parent nuclei must equal the total mass and charge of the protons of the emission and daughter nuclei. In other words, the left side and the right side have to add up. And I'm covering up this picture, but it's okay that I'm covering it up because I see if I have a total mass of 9 on the reactant side and I have a total mass of 4 in this helium here, this other piece over here is going to have to be 5, right? When I go backward and say 5 plus 4 equals 9. And if this is 4 on the bottom and here's 2, then it's got to be 2 on the bottom over here. We can figure out the math pretty easily, okay? All right, parent nuclei. This is the reactant nuclide on the left-hand side of the reaction arrow, right? Because it is a reactant. Product, right-hand side of the arrow, could be whatever the math comes out to be plus the alpha, beta, positron, or neutrons, or whatever the emission is going to be there. Alpha decay. I'm going to give off a helium nucleus. Mass is equal to 4. You can just look this thing right up, right? About what it is, but that's an alpha decay. Beta decay. This is an electron. It has no mass, but it does have charge. Positron, a positive electron, again, no mass, but it has a different charge, so that's going to change the bottom number a little bit. Sorry, I'm going fast, but you can pause. Neutron capture, when a parent nuclei, that's supposed to be nuclei, not nucle, that's nuclei, absorbs a neutron. It has a mass of 1, but has no charge because it's a neutron, duh. And the daughter nuclei is 1 AMU heavier, but proton number stays the same, usually used to start a fission reaction. Now we got to do some math right quick. I'm going to go through like 10 of these problems for you fast. And the deal is that the left side and the right side have to equal up. So it's all I'm going to do is look on the left side here, and I'm going to be like, yo, check it. There's a total nuclear charge of 9. So I'm going to go 9 minus 1 is 8. Now if I go the other way and go 8 plus 1 equals 9. Got it. So going from left to right, we're going to subtract. Going right to left, we're going to add. That's how it is. So I look up with 8 protons. I'm obviously oxygen. Then here I add these up. 14 and 4 is 18. 18 minus 1 is 17. So it's got to be an oxygen with a total mass of 17, which is not normal on your periodic table, but that's okay. Oh, sorry. It is an isotope. Now we got to do the same thing going the opposite way this way. Here I got 15 total nuclear charge or protons on the product side, so I need 15 on the other side. So 15 minus 13 is 2. Well, 2 protons is helium. And I got 31. 31 minus 27 is 4. So here's the normal helium that I'm adding to it. Okay, fission. All right, so now I'm going 96 plus 6 is 102. 102 minus 0 is 102. 102 is NO. I have 246 plus 12 is 258. 258 minus 4 is 254. Okay. 27 and 0 is 27. 27 is cobalt still. But now 59 and 1 is 60, so it's going to have a mass of 60. This one's going backwards. 43 and 0 is 43. 43 minus 1 is 42. 42 is MO. Then I have 98. 98 minus 1 is 97. So I did that fast in my head. Like bang. Okay, another set and we're out of here. Whoopsies. Let's see what happened. Just a weird animation. My bad. All right, so 83 plus 2 is 85. 0, right, plus 85 equals 85, so we're good. 85 is AT. Then I have 209 plus 4 is got to be 213. 213 minus 1 is 212. And 93 on the right-hand side, because 93 plus 0 is still 93. So 93 minus 92 is 1. Okay, and then I'm going to add these up. 238 and 2 times 1 is 2. That's 240. 240 minus 239 is 1. So now I got a, right? So I got a H with a 1 and a 1. Okay. I have stuff on the left-hand side. I got to solve for the right. I have 42 minus a negative 1. Yo, this is going to go up to 43. You got to be able to do that math quick in your head. Okay. Minus a negative is add. Then I have 98 plus 1 is 99. 99 minus 0 is 99. 43 is TC. All right, I'm going from right to left on this next one. 19 and 1 is 20. 20 minus 0 is 20. Bop. 20 is, I believe, calcium. And then I have 41 on the right-hand side, and I have 1 on the product. I'm sorry, 41 on the product side. I have 1 on the reactant side, so 1 plus what gets me to 41? 1 plus 40. There we go. I have a calcium isotope. All right, this one I see 1, 2, 3 on the right, and I see 1 on the left. So I need a 2. And then I see 1, 4. It's 5. 2 minus, or 2 plus what is going to give me to 5? That's going to be 3. Okay. So basically, we just got to make sure that the math is sound, that whatever total mass I have on the reactant side, I have on the product side, number of atomic charge or protons on the left-hand side is the same as the right-hand side. Just making it all add up, make sure it's even, and this is the easy part of the game. Okay? And with that, we're done with this video.